Hello friends. So today I will solve very most important question and also confusing question. So this is question of exercise 10.4 of a chapter circle. This is a little bit confusing question and I will solve this question by two method. And if you watch my video till the end, then you can able to understand this question very easily and you can also solve this question. I am going to solve this question by two method, and so please watch till the end. So the question is that two circles of radii 5 centimeter and 3 centimeter intersect at 2 points. The distance between their center is 4 centimeter. Find the length of the common chord. So in this question we have to find the length of the common chord of two intersecting circles. So here we can see that this is a two intersecting circle and this is a common chord. There are lots of the common chord, but there is a one sorry, there is a lots of the chords, but there is a one common chord, okay, which is this. Now we have to find the length of this common chord. Okay, so in question given that the radius of big circle is 5 centimeter, the radius of small circle is 3 centimeter, and the distance between their distance between the centers of a circle is 4 centimeter. Okay, now we have to find out the length of this common chord. So we already know the theorem. So theorem is that suppose there is a one circle and there is a chord, and if I draw a perpendicular from the center of circle to this chord, so it means that this perpendicular bisect this chord. It means that this chord will be cut into two equal parts. This part and this part will be equal if I draw a perpendicular from the center of circle to the chord. This is a theorem. Same as here we can see that there is a two circle, okay, and if I join the center of two intersecting circles is the perpendicular bisector of their common chord. Here we can see that the line joining the center of two intersecting circle is the perpendicular bisector of their common chord. It means that if I join the center of two intersecting circles, it means that this this line is a perpendicular bisector of this common chord. It means that this side and this side will be equal and there will be a 90-degree angle. There is no use of perpendicular, it means 90-degree. So there is a use of this bisector. Bisector means dividing into two equal part. So if I can able to find this length, then then after that the whatever I got the length of this part, I do twice of this part, then I will be get this total length. Okay, so let's find this length. Okay, so here we can see that this is making a triangle. Okay, sorry for my diagram, please try to understand. So suppose this is a dead triangle, okay, this is a 4, this is a 3, and this is a 5. So in class 9 there is a one chapter. The name of the chapter is Heron's formula. Heron's formula is used for finding the area of a triangle. Okay, so requirement of using Heron's formula is knowing all the length of the side of a triangle. Now here we know the all length of the side of a triangle, 5 4 3. So there is one very simple formula of Heron's formula, which is area of triangle is equal to under root s minus a, s minus b, s minus c. So here S means semi perimeter, and ABC is our length of the side of a triangle. So here we can see perimeter is of a triangle is 5 plus 4 plus 3 is 12. this is a perimeter, but S denotes semi perimeter, so we have to divide by 2. S is equal to 6. 6 is a semi perimeter. Okay, so let's find the area of triangle by using Heron's formula. So now putting value of S is 6. S minus A, 6 minus 5, suppose A is 5, then 6 minus 3, then 6 minus 4. So here 6 into 1 into 3 into 2. Here we can see that 6 into 6. So in under root there is a one pair, so we can take 6. Okay, so now we know the area of this triangle is 6. Okay, we also know another formula of finding the area of triangle, which is half into base into height. You know na, also second formula of area, which is half into base into height. Okay, so this area of triangle, and by using this formula is same. It means that both are having same area of triangle na, but uh, uh, this the way of finding is different. Now here we use Heron's formula, and here we use half into base into height. So we already know area is 6. Now put the value of this half base. What is base? Here we can see that base is 4, and here we don't know height, we denote height by h. Okay, so base is 4, h, height is h, equal to 6. 2 ones are 2, 2 twos are, then this 2 will be goes in denominator, it means 2 ones are 2, 2 threes are, h equal to 3. So h equal to 3. So now we get this h is 3. Now if I do twice of 3, I will get 6. 6 is chord. Why I did twice of this 3? Because we have to find total length of this common chord, and this is the 3, so total length will be a 6. I did twice because this theorem. If I draw perpendicular from the center of a circle to chord, then that perpendicular bisect this chord. Bisect means dividing into two equal parts. Suppose this is 3, this part is 3, then total part will be a 6. So this is a 6. So length of the common chord is 6. So if you want to solve it by another method, so I have also another method. Okay, if you don't want to use this Heron's formula. So we had this triangle. Okay, we had this triangle. This is 4, this is 5, and this is 3. And here we know also this line is making this line is intersecting this chord at perpendicular bisector. Okay, so here is a common chord which is making 90-degree, because perpendicular means 90-degree, and intersecting this chord into two equal part. So this is making 90-degree, this is a symbol of 90-degree. Now we can see there is a two right angle triangle, 1 and 2. By using 1 and 2 we can find this length. Okay, so we know that we can use Pythagoras theorem in right angle triangle. This is a right angle triangle. Suppose this is a perpendicular, this length is perpendicular. Now in first triangle we can see hypotenuse square means 5 square base suppose this total and this not, suppose this is given 4. Suppose this is x from here to here, then this will become 4 minus x. This will become 4 minus x if this is x. So in first triangle, hypotenuse square means 5p square, base square means x square, this perpendicular square means p square. In second triangle also we can see that hypotenuse is 3 square, then equal to base is 4 minus x square, then perpendicular is same. Here perpendicular p is common, so p square. Now finding p square. P is equal to 5p square means 25, x will be a minus x square. Here p square, then here we will get 9 minus 16 minus x square plus 8x. If left hand side is equal, then right hand side will be also equal. Then p square, then right hand side will be also equal. 25 minus x square is equal to 9 minus 16 equal to minus 7 minus x square plus 8x. This x square and this minus x square will cut, because if I change the side of this x square, this will become plus x square, this will be cancel out. Then 25 plus 7, because this is minus 7, and if I change the side, this will become plus 7 equal to 8x. Then x will be equal to 32 by 8. X equal to 8 for the 32. Now don't surprise by x equal to 4. Don't suppose here x will be equal to 3, then twice of 3 is 6. Okay, don't suppose that, because x is this length and we are looking to find value of p. Then we will do twice of p. Okay, so put the value of x in this right angle triangle, then we will get value of p perpendicular, then we can do twice of this. So here in suppose this is a equation 1. By first triangle, right angle triangle, this will be a 25 is equal to x square means 4 square means 16 plus p square, then p will be equal to plus minus 3. Length of the side never be in negative, so p will be equal to 3. Now we have to do twice of 3 because we know the theorems, and then doing the twice of 3 it will become 6. Reason you know, if I draw a perpendicular from the center of circle, then this perpendicular bisect this chord. Okay, so 6 is answer. Thanks for watching.